Good morning. Now I'm going to take a seminar on hydraulics and its principle. The contents we will see in this topic are the principle of fluid power and hydraulics, applications of hydraulics in various fields, properties of fluids, Pascal law and application, signal flow in hydraulic system, symbolic representation, working principle, basic hydraulic circuits used in different applications, the practice on workstations, and the practice of fluids in hydraulics. First is introduction. The control movement of the parts or a control application of the force is a common requirement in industries. These operations are performed mainly by using electrical machines or diesel, petrol, and steam engines as a prime mover. What is fluid power? Fluid power is electrical science and technology that deal with generation, control, transmission of energy through use of pressurized fluids. Fluid power technology is used to convert, transmit, control, and apply fluid energy to perform useful work. Hydraulics, the study of hydraulics deals with a system operator with hydraulic oil media to impart power to the control system. Hydraulic power pressurized oil be used to power engines or to control or to regulate machines. Uh, Now we'll see the historic review. Actual advancement of oil hydraulics started from the end of 13th century. In 1648, French physicist Pascal discovered a fundamental law under the whole science of hydraulics. It is a two-part statements as given here. Pressure at any point in a static fluid is same at every direction. The pressure exerted on the confined fluid is transmitted equally in all directions, acting with the equal forces on equal areas. The next we will see the basics of the principle of hydraulics. Every body exerts a specific pressure on its base. The value of this pressure is dependent on the force due to the weight of the body and on the size of the area on which the force due to weight acts. It was given by a formula P is equal to F divided by A, P is equal to pressure, F is equal to force, area, A is equal to area. The first is pressure transmission. If a force F1 acts via an area 1 on an enclosed fluid, a pressure P is produced which extends throughout the whole of the liquid. The same pressure applies at every point of the closed system. The same pressure acts on the surface A1, A3 and as on A1. It was given by a formula P is equal to F divided by A. And next is power transmission. The same pressure applies at every point in a closed system. For this reason, the shape of the container has no significance. When the container is formed as shown in the figure, it is possible to transmit the forces. The fluid pressure can be described by means of following equations, which can do P1 and P2. P1 equal to F1 divided by A1, P2 equal to F2 divided by A2. There are two types of flow. One is laminar flow and the turbulent flow. The hydraulic system consists of many parts such as cylinder, storage tank, filter, electric pump, pressure regulator, control valve, leak proof, closed loop. This is a schematic representation of the hydraulic system. Next slide you will see the working principle. The storage fluid tank is a reservoir of high fluid used as a transition media. The liquid used is generally high density incompressible oil. It is filtered to remove dust or any other unwanted particles and then pumped by a hydraulic pump. The capacity of the pump depends on the hydraulic system design. These pumps generally deliver constant volume in each revolution of the pump shaft. The pressure regulator is used to avoid such a circumstance which redirect the excess fluid back to the storage tank. The movement of pistons is controlled by changing liquid flow from port A and port B. The cylinder movement is controlled by using control valve which directs the fluid flow. The leak proofing piping is also important due to safety, environmental hazards and economical aspects. The next is a types of hydraulics. The types of hydraulics were stationary hydraulics and mobile hydraulics. In stationary hydraulics is fixed at one station where all activities is carried out at the same station. Stationary hydraulics is used in machines tool applications. The following applications areas are important for stationary hydraulics: production and assembly machines of all types, transfer lines, lifting and conveying devices, presses, injection molding machines, rolling lines, and lift. The next is the mobile hydraulic, and the mobile hydraulic system move on wheels or tracks. For example, unlike stationary hydraulic system which remain firmly fixed in one position. A characteristic feature of the mobile hydraulic is that valves are frequently manual operated. Typical application fields of mobile hydraulics include construction machinery, elevating platforms, lifting and conveying devices, and agriculture machinery. Thank you.